This is topic 8, lesson 1, using variables to write expressions. How do you turn word problems into algebraic expressions using variables? So in this case, we're going to talk about how you take an expression, a word problem, and turn it into an algebraic expression that uses variables that will help us solve the word problem. So a variable is a quantity that can change or vary and is often represented by a letter. Variables help you translate word phrases into algebraic expressions. So a variable is is an unknown quantity. It could be a whole number. It could be a decimal. Any kind of any amount, and it is oftentimes it's represented with a letter, a lowercase letter, typically an X or a Y or an N. Sometimes you can use a letter like apples. You could use an A. A number you could use N. Otherwise you would use X. Any of those work fine. And an algebraic expression is a math phrase that has at least one variable in one operation. So, and the key here is that it has to have one variable. So if it's an algebraic expression, not just a regular old expression, remember I'm going to say this for I don't know how many times, an expression does not have an equal sign, but an algebraic expression has one variable with at least one operation. It can have more than one operation, but it has to have at least one operation. So like addition, subtraction, multiplication, or division. So here's our word problem. John bought 4 video games. Each game cost $19.95. Write an expression. We're going to write just a regular old expression to show how much he spent. And so to do that, did a little chart here. And if he bought one game, our expression would be 1 times 19.95. If he bought 2 games, it would be 2 times 19.95. If he bought 3 games, it would be 3 times 19.95. So consequently, if it was 4 games, he would have bought 4 times 19.95. Or you could have done 1995 plus 1995, 1995 plus 1995 plus 1995, 1995 plus 1995 plus 1995 plus 1995. It's just that it would get a little bit long. It's not terribly useful. So here's our answer for our question here is 4 times 1995. Or, right, because of what property? Yes, the commutative property. You could go either direction. Now, our question is, so if you were going to write an algebraic expression that would work with any number of purchases. So if we go back to our algebraic, it has to have at least one variable in one operation. So for this is for any number purchased. So not just 1 or 2 or 5 or 6, for any number purchased, I'm going to use n for my variable. It would be n times 1995. So that would be for 5, that would work for 6, that would work for 20, that would work for 100. You just substitute that whatever number it is of the number of video games purchased for that n. So 3 times 1995 would be for 3. If you bought 7, it would be 7 times 1995. But to make a generic expression that would work for any number purchased, it would be n times 1995. Now, there are different keywords that kind of help us with this. So a number increased by 5 would be a number increased by 5. I didn't type right. A number, and these next two are a little bit tricky. A number decreased by 3 would be n minus 3, right? So it's a number, and it's decreased by 3. This is the difference of 7 and a number. So it's 7 minus n, the difference of 7 and a number. You almost kind of just have to read them in order. Oftentimes that kind of helps you. But that's the difference between decreased by and difference. Both of them are subtraction, but the order is a little bit different. A little bit different. It's opposite. And 3 times a number would be 3 times a number. Now, you could have, and this could also be the same as 3n. When you put a variable next to a number, it means multiplication. And oftentimes we do that because this x will get confused with x variables. So a number next to a variable means multiplication. They're also like 5 divided by a number would be 5 divided by n. The sum of 4 and a number would be 4 plus n. So there are other ones as well. Most of them are ones that you're probably pretty familiar with because they are ones that we use like in word problems. So why don't you try it? And I came up with, I have to say, two tough words. One of them in particular. This one in particular is a little bit tricky. Um, but I put two to make it a little bit more difficult. You're going to have two um, operations in each of these. Why don't you take a peek at these? So 5 times a number increased by 2 would be 5 times. Oh, and you got to have parentheses for these. A number increased by 2. So this would be 5 times. So we have the number increased by 2, and we have to have 5 times that. 4 less than a number times 6. Now this is a little bit tricky. So we have a number times 6 would be n times 6. That's part in parentheses. We want 4 less than that. So it's going to go like that. 4 less than a number times 6. A number times 6, we want 4 less than it. So it would be n times 6 minus 4. And that is how you write an algebraic expression with a variable to help you solve a word problem. Thank you for listening.